Hello everyone and welcome to this video. Here I want to go over the differentiation formulas. And I called it part one because they're pretty long, so I'm gonna try to do that in 2 or 3 videos. First of all, let's go over the notation. I went over this in the last video, but if you have a function y equals to f of x, so the first derivative, there's several ways you can write the first derivative. You can say it's y prime equals to f prime of x, and that's the same thing as dy dx or df of x over dx. And sometimes you might see this notation, df of x or d sub x f of x. These are just operators. The meaning of those means that find the derivative of y or f of s with respect to x. I have a couple of notes here. This notation was created by Leibniz, and he was a 17th century mathematician and a philosopher. What does that mean? Is deriving y with respect to the variable x. And later on in your, this is going to make more and more sense to you. Dy dx is just the limit as delta x difference in x approaches to 0 of dy delta y over delta x. That means it's very, very small, and we call that infinitesimal. So as you take more math classes, this is going to make more and more sense to you. The second derivative is y double prime of x, and this is f double prime of x, and this just means find the derivative of dy dx with respect to the variable x. And again, this is the Leibniz notation. If we multiply across, then we get d times dy is d squared y over dx squared. Higher order derivatives, the third derivative, again, that's y triple prime of x, which is the same thing as f triple prime of x, and it's d over dx. Again, this means find the derivative of whatever function you have here, and then find the derivative of the second derivative here, and that can be written as, again, d times d is d cubed, and dx times dx squared d is dx cubed, and so on. You can have the fourth, fifth, and the higher order derivatives. Now, if you want to find the derivative at a point x equals to a, you can write that. This is rare, but I put it anyway. It's y prime of a, which is the same thing as f prime of a, and it is the same thing as dy dx, and you just draw a line at x equals to a. This means find the derivative first and evaluate it at x equals to a. So please get familiar with those notations, because you're going to see all of them. Now let's start. Let's talk about the derivative of a constant. In my last video, I talked about the limit definition of the derivative, but in this video, we're going to talk about different rules. First, let's talk about the derivative of a constant. When y equals to f of x equals to c, a constant, that means it's a number. The derivative of a constant is always 0, and you can just show that by using the limit definition of a derivative. So if prime of x is limit as h approaches to 0 of f of x plus h minus f of x over h. And please remember, each time you want to prove a derivative, you just can go to this formula. So that's limit as h approaches to 0. So f of x plus h is just c, because there's no x in there, minus c over h. And that's going to be limit as h approaches to 0 of 0 over h. And this is just limit as h approaches to 0 of 0, which is 0. A constant, if you draw a constant, you get a horizontal line. And we know the slope of a horizontal line is always 0, and I put the note here for you. Now the first rule we're gonna learn is called the power rule. Again, these rules or formulas are shortcuts to find the derivative of functions and not using the limit definition of the derivative all the time. So it says f of x equals to x to the n power. Then f prime of x is n times x to the power of n minus 1. So the proof of this, I'll show it to you in my next video, but just learn how to use it. That's the goal of this video. So, or you can say, I put some notes here for you. The first one, the derivative of x to the power of n is n times x to the power of n minus 1. Sometimes the exponent can be negative, but you use the same thing. If f of x equals to x to the power of negative n, then f prime of x is going to be negative n to the power of negative n minus 1, and that's for negative exponent. Sometimes you can have a rational or fractional exponent, but this doesn't change. So x to the power of a over b, if f of x is that, x to the power of a over b, use the same rule. F prime of x is going to be a over b times a over b minus 1. If you have a constant in front of your function or the term, so then f prime of x is going to be n times ax to the power of n minus 1. Let's go over some examples, and this is going to make sense to you. Simple one. If f of x is x cubed, then f prime of x is going to be 3 times x to the power of 3 minus 1, which is 3x squared, and you can do this in one step. If you see it, do it fast. There's nothing wrong with that. F of x equals to 5x to the 4th power. F prime of x is going to be 5 times 4x cubed, or just go directly to 20x cubed. Again, 5 times 4 is 20. F of x equals to x. We know the exponent of x is 1. If I do that slowly using the rule, is 1 times x to the power of 1 minus 1 is x to the power of 0. We know any number to the power of 0 is 1. So the derivative of x is always 1. If you have a constant, f of x equals to 4x, f prime of x is 4. Now, if you have a polynomial or any function like that, f of x equals to 4x cubed plus 3x squared minus 2x plus 1, just take the derivative of each term one by one. F prime of x is going to be 3 times 4 is 12x squared. And again, learn how to do this fast and get used to this formula. The derivative of 3x squared, 2 times 3 is 6x. And again, you do minus 1 here. The derivative of negative 2x is negative 2. And the derivative of 1 being a constant is 0. So the final answer is 12x squared plus 6x minus 2. Now, if you're dividing a polynomial, that's a binomial, by a monomial, and don't forget the denominator. If the denominator is a monomial, that means only one term. So if you want to find the derivative of f of x first, divide its size, so separate them. That's x squared over x plus 2x over x. And simplify, you get x plus 2. Your x squared over x is x, 2x, x is cancelled, is plus 2. Then find f prime of x. F prime of that term x is just 1, and f prime of 2 is 0. So the answer is 1. Next one, if you have f of x equals to 1 over x, first make the function in a way so you can use the power rule. Write this as x to the power of negative 1. Again, 1 over x is the same thing as x to the power of negative 1. Once you make it ready for the derivative, then you can use the power rule. So this is negative 1 times x to the power of negative 1 minus 1. That's negative 1x to the power of negative 2. do not keep the negative exponent, make it positive again, so it's negative 1 over x squared. Let's do another example. F of x equals to 3 over x to the fourth power. This can be written as, it's still f of x. I'm not finding the derivative. So first, make it the way so you can use the power rule. So you write this as 3x to the power of negative 4. Then find f prime of x. Negative 4 times 3 is negative 12. Negative 4 minus 1 is negative 5. So it's negative 12x to the power of negative 5. Or you can write this with a positive exponent, negative 12 over x to the fifth power. Now again, this is a polynomial, and you divide that by a monomial, just one term. If you want to find the derivative of this function, again, use some algebra first, rules of exponents, separate them. So first, 3x cubed over x squared is just 3x, and you don't have to write x squared each time. You can just do this with faster steps. 4x squared divided by x squared is 4. Negative 2x over x squared is negative 2 over x. And 3 over x squared is 3 over x squared. So separate them. Still not done. 3x equals okay. 4 is okay. 2 over x can be written as, well, it's negative 2. Negative 2x to the power of negative 1. And 3 over x squared can be written as 3 times x to the power of negative 2. Now this is ready for the power rule. The derivative of 3x is 3. The derivative of 4 is 0. The derivative of negative 2x to the power of negative 1. Negative 1 times negative 2 is just 2x to the power of negative 1 minus 1 is negative 2. Negative 2 times 3 is negative 6, and negative 2 minus 1 is negative 3. One more time, do not keep the negative exponent, change them back to positive exponents. So 3 is right here, 0, you don't have to write it. 2x to the power of negative 2 is the same as 2 over x squared, and negative 6 times x to the power of negative 3 is the same thing as negative 6 over x cubed. Now in this example, if you want to find the derivative of square root of x, first change it to rational exponent or fractional exponent. Square root of x is the same as x to the power of 1/2. We already know that. And I put the note for you, nth root of x can be written as x to the power of 1 over n. And this will work all the time. So this is ready now. So the derivative is going to be 1/2 x to the power of 1/2 minus 1. That's 1/2 x to the power of 1/2 minus 2 over 2. And that's negative 1/2. Change it to positive exponent. So it's 1 over x to the power of 1/2. And x to the power of 1/2 here is square root of x. If the problem has radicals, the answers must be with radicals also. Let's go over this example. 3x squared plus 2x plus 1 divided by cube root of x. First step, change cube root of x to a rational exponent. So it's x to the power of 1/3. And again, separate them. So then you just divide. So this is 3x to the power of 2 minus 1/3. And again, from algebra, we know a to the power of n divided by a to the power of n. You subtract the exponent. The second term is to the 2x1 minus 1/3. And finally, this one, make it the way so you can take the derivative. So it's x to the power of negative 1/3. So 2 minus 1/3 is 5 over 3. 1 minus 1/3 is 2 over 3. And this is ready. Now that you have made it ready for taking the derivative, write f prime of x equals to 5 over 3 times 3 is just 5. X to the power of 5 over 3 minus 1. 2 over 3 times 2 is 4 over 3x to the power of 2 over 3 minus 1. And this one is negative 1 over 3 times negative 1 over 3 minus 1. Now 5 over 3 minus 1 is 2 over 3. So we have 5x to the power of 2 over 3. Here 4 over 3x to the power of 2 over 3 minus 1 is 2 over 3 minus 3 over 3, which is negative 1 over 3. And negative 1 over 3 minus 1 is negative 4 over 3. Now this problem had a radical, so we have to change back the answers to radical, but let's see how we can do that. So x to the power of 2/3 is the same thing as cube root of x squared. Again, the denominator goes here, so it's cube root of x squared. X to the power of negative 1/3, first bring it down, make it positive 1/3, and that's x to the power of 1/3, which is cube root of x. And finally, this can be written as 1 over 3 cube root of, again, cube root of x4. However, here we can still simplify this. Cube root of x4 is cube root of x cubed times x, and you can take that out. So it's x cube root of x. So the final answer is 5 times cube root of x squared plus 4 over 3 cube root of x and minus 1 over 3x cube root of x. Now I did some notes here for you from algebra, so let's go over those. If you have x to the power of 3 over 2, we know we can write that as square root of x cubed, but this can be simplified. Square root of x cubed is x squared times x. Take x squared out, it becomes x, so it's x square root of x. And try to remember that x to the power of 3 over 2 is always x times square root of x. X to the power of 6 over 5 can be written as 5th root of x to the 6th power. Again, that number, the denominator is here, and that's the exponent of the radicand. But I can still simplify this. X to the 6th power can be written as x to the 5th power times x. We can take this out again. When you take it out, you divide that. Those two numbers, 5 divided by 5 is 1. So it's x 5th root of x. Last one, x to the power of 7 over 3 can be written as first cube root of x to the power of 7. But you want to take a number, separate those so you can divide that by 3. So you can write this as x to the 6th power times x. And again, 6 divided by 3. You take it out and you write x squared cube root of x. I wrote the rules of exponents from algebra here. I think it's good to have it. Again, a to the power of n times a to the power of n. When you multiply two numbers with the same base, you can add the exponents. When you divide two numbers with the same base, you can subtract the exponents. Exponent to exponent, you can multiply them. And if the exponent is negative, you can bring it to the denominator and make it positive. If you have a fraction to a negative exponent, you can flip the fraction and write b over a to the power of n. And again, that's the same thing as b to the power of n over a to the power of n. And any number to the power of 0 is always 1. Let's go over the summary of what we did. The derivative of a constant, just remember, is always 0. The power rule, the derivative of x to the power of n is n, x to the power of n minus 1. If you multiply, your function is multiplied by a constant, so the derivative of c f or c f prime is the same thing as c times f prime. When you add or subtract two functions, you can find the derivatives separately. F g prime is f prime g plus g prime. This is the product rule. I put it here, but I'm going to talk about this in the next video in detail. And this is the quotient rule. Get familiar with that. The derivative of f over g is f prime g minus g prime f over g squared. So just remember these two formulas. That's going to be the topic of the next video. And I think that's enough for this video. Thank you for watching. Have a good one, everyone, and I'll see you in my next video.